Another thing that we're going to do is graphing these logarithmic functions. Now, what I have on the screen are the three base order pairs that we use for graphing regular exponential functions. But again, inverses means switching the x and the y. So I will switch the x and the y for each of these ordered pairs. And these are going to be my base ordered pairs that I'm going to use for the logarithmic functions. Now, the general form of a logarithm function is a times log base b of x plus or minus h plus or minus k. Now again, all those letters represent a lot of the same things that we've already talked about in transformations with horizontal movements, vertical movements, stretching and compressing and reflecting. All that stuff is going to stay same. So the steps that I want to use is I will use the opposite of h to not draw a horizontal, but to draw a vertical asymptote now. 2, I'm going to use the base b to find the three base ordered pairs. 1 over b, negative 1, 1, 0, b1. Step 3, I'm going to multiply my y values by a if necessary. And then I'm going to add or subtract by k to those y values. Step 4, I will add or subtract the opposite of h to my x values if necessary. And step 5, I'll plot those points that I come up with and I'll draw my graph. So let's look at an example. Log base 2 of x. I'm going to rewrite this in a form that matches the general form that I showed you in the previous slide. If you see the zeros there, step 1 tells you that you have a vertical asymptote at x equals 0. Step 2, the base in this particular problem is a 2, so when I plug in the 2 for a b, I have 1/2 comma negative 1, 1 comma 0, 2 comma 1. Step 3, I don't have an a value. I do not have a k value that's going to change the y values in my ordered pairs, so I will skip that step. And step 4, I don't have an h value that's going to change the ordered pairs either because it's a 0. So I go to step 5, graph my dots, draw the line, and that's what log base 2 of x will look like. Got a couple more examples for you. 3 times the log base 10 of x plus 1. Now there might be confusions as, is that plus 1 with the x or is it on the outside? So if I rearrange the problem, I have inside with the x it's a plus 0 and on the outside it's a plus 1. So that kind of signifies what your h is and what your k is. I'm going to go through those steps again. So now that I've got that 0, it tells me again that I have a vertical asymptote at x equals 0. Step 2, my base is a 10, so I'm going to use that to find my three base ordered pairs. 1 over 10, comma negative 1, 1, 0, 10, comma 1. Step 3, multiply my y values by a 3. So I'll go through each one of those and multiply them by 3. And then after I multiply by 3, I'm going to add a 1 to that number. So there are my new y values. Step 4, adding 0 to the x values are not going to change the values. So the numbers that you see there for your ordered pairs are the ones that you're going to plot. I plot those three ordered pairs, draw the graph, and there's the graph for 3 times the log base 10 of x plus 1. One more example. F of x is equal to 2 times the log base 3 of x minus 2. So I got the number inside. I use the opposite, it says minus 2, so I have a vertical asymptote at positive 2. 3 base ordered pairs. Notice that the base is a 3. So now I got 1 over 3, negative 1, 1, 0, 3, 1. Go to step 3. Multiply my y values by a 2. Then add 0. Notice that I actually didn't have a number on the outside there, so that means adding 0. So I'm going to multiply all of my y values by 2. Step 4, add 2, add the opposite of the h value to the x values. So each one of those x values that I have in there will have a plus 2 to it, and I get new ordered pairs of 2 and 1/3, comma negative 2, 3 comma 0, 5 comma 2. Those are the three ordered pairs that I will plot. Once I get them plotted, then I can draw my graph, and there's your final graph for the 2 times the log base 3 of x minus 2. One application that we're going to look at here, and we have the Richter scale, which measures earthquake intensity. The increase in intensity between each number is 10 times. So for example, an earthquake with a rating of 7 is 10 times more intense than one measuring 6. The intensity of an earthquake can be modeled by the following equation: y equals 10 to the x minus 1 power, where x is the Richter scale rating. Now we're going to use this information over here on the left to find the intensity of the strongest recorded earthquake in the United States. Now it says the largest recorded earthquake in the United States with a magnitude of 9.2. That struck Prince William Sound, Alaska on Good Friday on March 28, 1964. So that 9.2 that is in there, that is my x value that we're going to end up plugging into the equation. So if I replace it, I can simplify. 9.2 minus 1 is going to give us 8.2. I can use the calculator. 10 to the 8.2 power. Pretty big number. 158,489,319.2 for the magnitude. Next thing that we're going to look at. We're going to take that equation, y equals 10 to the x minus 1, and we're going to write it in the form of a logarithm. So here we have that. Now if I use the arrow system where I drop my base, let me back up there. First we need to switch our x and the y because we're finding the inverse. And then I'm going to convert it into logarithm form. So I drop my base. The exponent of x minus 1 is going to come over to the opposite side, and what it is equal to, the x, will come over to the log. Now if I'm solving for an inverse, the last step was to get the y by itself, so that y minus 1, I need to add 1 over to both sides to get the y by itself. So in this form, y equals log base 10 of x plus 1.